Hi, welcome to NewTech YouTube channel. In this video, we are going to study and solve example on Norton's theorem. Let's begin. The Norton's theorem, also called as Mayer-Norton's theorem, where Hans Ferdinand Mayer is a German mathematician and physicist, and Edward Lowery Norton is an Bell Labs engineer. The Norton's theorem individually derived by them. Now let's study important key terms. First key term, bilateral circuit statement. The network or circuit allows to current flow in both directions. Second key term, Norton's current IN statement. It is a short circuit current at the terminals. Third key term, Norton's resistance Rn statement. Input or equivalent resistance at the terminals when the independent sources are turned off from the given circuit or a network. We just studied some important key terms. Now let's study statement of Norton's theorem. Sometimes Norton's theorem also called as converse of Thevenin's theorem. Now see statement. A linear and bidirectional two-terminal network can be replaced by an equivalent network consisting of a current source connected in parallel with a resistor. Means we get simplified network or circuit as a current source IN with parallelly connected resistor RN. Now learn more about circuit representation using Norton's theorem as refer the diagram. A given linear and bilateral network with load resistor can be replaced by an Norton's equivalent circuit as short circuit current or Norton's current IN in parallel with equivalent resistance or Norton's resistance RN along with load resistor RL. Up till now, we have studied important key terms, statement of Norton's theorem, and circuit representation using the same. Let's study procedure of Norton's theorem. Step 1. Remove the load in a given network or circuit and label the open terminals as A and B. Procedure Step 2. Calculate the short circuit current IN at the load terminals labeled as A and B after disconnecting the load resistance RL. Here, in general, one can apply any one of the following techniques such as mesh analysis, node analysis, superposition theorem, and Thevenin's theorem, etc., which are studied earlier. If you are interested to learn these techniques, I will give you the link of the same in the description. Procedure Step 3. Calculate the resistance that would exist between the load terminals at A and B, that is Norton's resistance RN, along with if it is a voltage source, short circuit it, or if it is a current source, then open circuit the same in the given network or circuit at the time of calculation of equivalent resistance or Norton resistance at the terminals A and B. Procedure Step 4. Draw new Norton's equivalent circuit using Norton's current IN, Norton's resistance RN, and load resistance RL, and then calculate required circuit parameters such as load current, etc. Using procedure of Norton's theorem, let's solve example on the same. Example statement. Use the Norton's equivalent circuit to calculate the current IL through load resistor RL. Let's see given data. Current source IA is equal to 8 milliampere. Resistor R1 is equal to 1 kilo ohm. Resistor R2 is equal to 2 kilo ohm. and resistor R3 is equal to 3 kilo ohm along with load resistance RL is equal to 12 kilo ohm. Now using the above data, find current through load resistance RL. Now using previously studied procedure, find the solution of the example. Step 1. Remove the load RL and label the terminals as A and B. Let's see the diagram. We have removed the load RL and labeled the terminals as A and B. Solution. Step 2. Part A. Calculate the short circuit current at the load terminals across A and B as a Norton's current IN. Refer the diagram. We have measuring short circuit current IN across the terminals A and B. Solution. Step 2. Part B. By short circuiting terminals at A and B, which also short circuit resistance of 3 kilo ohm, then find Norton's current IN using the same diagram. Solution. Step 2. Part C. Now using current division concept, calculate the value of short circuit current IN or Norton's current. Formula. Short circuit current IN is equal to resistor R1 upon resistor R1 plus R2 into source current IA. Now substitute. Source current IA is equal to 8 milliampere, resistor R1 is equal to 1 kilo ohm and R2 is equal to 2 kilo ohm. Therefore IN is equal to 1 kilo ohm divided by 1 kilo ohm plus 2 kilo ohm into 8 milliampere. After calculation, we get value of short circuit current or Norton's current IN is equal to 2.66 milliampere, and this is the important step in Norton's theorem. Procedure. Step 3. We are calculating the resistance that would exist between the load terminals at A and B, that is, we are finding value of Norton's resistance Rn. For the diagram, resistor R1 and R2 are in series and resistor R3 is in parallel with resistor R1 plus R2. Then value of Norton's resistance or equivalent resistance Rn is calculated as resistor Rn is equal to resistor R1 plus R2 parallel with resistor R3. Now using previously studied diagram of calculating Norton's resistance Rn and the formula of the same, refer the previously studied formula where Rn is equal to resistor R1 plus R2 parallel with resistor R3, which is equal to resistor R1 plus R2 into resistor R3 divided by resistor R1 plus R2 plus R3. Now substitute value of resistor R1 is equal to 1 kilo ohm, R2 is equal to 2 kilo ohm and resistor R3 is equal to 3 kilo ohm. After calculation, we get value of Norton's resistance Rn is equal to 1.5 kilo ohm. Please note that do the calculations carefully. Procedure. Step 4. Part A. Using the calculated parameters such as Norton's current IN and Norton's resistance Rn, now draw Norton's equivalent circuit as, refer the diagram. Norton's current IN is equal to 2.66 milliampere is connected in parallel with Norton's resistance of 1.5 kilo ohm and load resistance of 12 kilo ohm. Using new Norton's equivalent circuit, we are finding value of load current using formula as load current IL is equal to Norton's resistance Rn divided by Norton's resistance Rn plus load resistance RL into Norton's current IN. Please note it, sometimes in MCQ type questions, they may ask the load current formula or calculation of load current using the same formula. Procedure step 4 part B. Let's calculate value of load current IL as formula. Load current IL is equal to Norton resistance Rn divided by Norton's resistance Rn plus load resistance RL into Norton's current IN. Substitute value of Norton's current IN is equal to 2.66 milliampere. Norton's resistance Rn is equal to 1.5 kilo ohm and load resistance RL is equal to 12 kilo ohm. And then after calculation we get load current IL is equal to 0.2955 milliampere, and this is our required result. Just a recap, in this video we have studied important key terms, statement of Norton's theorem, procedure of Norton's theorem, and then solved the example and calculated value of load current. Thanks for watching my YouTube channel. Thank you.